This is Unit 4, Linear Equations and Linear Systems, and this is Lesson 9, When Are They the Same? And Activity 1, which would you choose? Now, Unit 4 is all about linear equations and linear systems, and we spent some time up until now learning about linear equations. And now we're going to move into looking at more than one linear equation and how do they fit together. What's the relationship between those multiple equations? And that's called a linear system. But I want to go back to this title of linear equations and linear systems because this is what I focus on when I look at these problems. Where is the linear relationship in these problems? And this kind of bothered me in this first activity because this situation, so there's two babysitting jobs, one $5, charged $5 for the first hour and $8 for each additional hour. The other job is to charge $15 for the first hour and $6 for each additional hour. And it asks to explain the difference and which would you prefer. And as I looked at this, I realized that it's $5 for the first hour and then $8 thereafter, and then each additional hour, and then $15 for the first hour and $6 thereafter for each additional hour. Now that we've seen this before, but usually this beginning amount to form a linear equation, this beginning amount is at time 0. So the babysitter shows up and she gets $5 for showing up at the door, and charges $8 for each hour. And in the second situation, $15 for showing up at the door and charges $6 for each additional hour. That would be a linear relationship. That would be starting at 0 and then charging an equal amount per hour thereafter. That would be the slope of the line. So I'm going to go into this in a little bit of detail. So let's put this into a table. So start at 0 time. After the first hour, makes $5 and $15. Second hour, $13.21, and it goes up. This goes up $8 each hour, so $5, $13, $21, $29, and so on. And this job goes up at $6 per hour. So it starts at a higher amount, but goes up at a lower rate, actually $2 per hour lower. So 15, 21, 27, 33. So when do they match? Well, notice that the difference with the first hour is $10, and they go up. This one starts out lower, but goes up $2 faster for each hour. Starts out at $5, earns $8 each hour. This one starts out at a higher amount, $15, but goes up at $6 per hour, so $2 less. So what that means is that each hour, this first job is going to catch up to the second job by $2 each hour. So this difference is $10, this difference is $8, this difference is $6, this difference is $4, this difference is $2, and when do they finally match? They match at 6 hours at $45 total. So if you start looking at this as a graph, now I'm going to draw a lot of graphs during this lesson, and I don't think the authors really expect that, but we've had a lot of lessons on graphing linear equations. So why not? Why not add that to your knowledge of looking at these problems? So let's draw a graph of both of these situations. Now, these are not linear equations. This equation starts out at 0, and after 1 hour is $5, 2 hours 13, 2 hours 13. So in this first hour, there's a change of $5. But then thereafter, the second hour, there's a change of $8, third hour, a change of $8. So that is not a linear equation. I'm going to zoom in. And so through 0, 0, it's 0, 0 is when babysitter shows up at the door, they've not made any money yet. That is not on this line. Actually, this line goes to this point right here, which is actually -3. So I'm going to get to that in just a moment. The point is it's not linear. So how do you write an equation for this line after this first hour? So this part, let's say this is all the information you have. How do you write an equation for that? You figure out the slope, so the change in 1 hour, so going from 1 hour to 2 hours, so that change in that 1 hour is $8. So take this point right here, 13 minus 5, that's a change of $8 in that 1 hour, 2 minus 1. So that's a slope of 8. So now you know what the slope is, and how do you figure out the equation? Well, you take any other point on this line, and let's say that this 0.15, so after 1 hour you earn $5. Let's say that that is the beginning point. You choose any other point on this line and call it xy. And so you have to remove the $5 from the y coordinate, y minus 5, and you have to remove the $1 from the x coordinate, x minus 1. So you're moving this slope triangle. We've done a lot of work on that. We're lowering the slope triangle by 5 units along the y-axis, and we're moving it over 1 unit along the x-axis. And what that tells you is that the change along the y-axis is 8 times more than the change along the x-axis. That is the slope, and however much the value changes along the y-axis, the length along the y-axis, that is 8 times greater than the length along the x-axis. And that makes sense. For each hour, you make $8. 2 hours, you make $16. 3 hours, you make $24. But you're not starting out at 0, so you have to take that into account. You're starting out here somewhere. So you get this equation, y equals 8x, so the slope is 8, but it's starting now at -3. So starting down here at -3, and you go up here, if you're at $5 for the first hour, if it's $8 per hour, you go back to time 0, that is going to be -3. That's on the line. And we can come up with a story for that, and I will do that in just a few moments. But let's cover the line for the second situation. So in the second case, now this is easier to see that 0, 0 down here is not on this line. So this line goes through, and we're going to figure this out in a second, it actually goes through $9. So what I'm going to do is figure out the slope by taking this first hour. What's the change during this first hour from 1 hour to 2 hours? What's the change during that 1 hour? Well, it goes from $15 to $21, so that change is 6. That's the slope. 21 minus 15 is that change for this 1 hour, 2 minus 1. So here's the slope. Now, how do I write the equation given that slope? I'm going to choose any other one of these points I want. I'm going to call it xy, and I have to take away this point right here. I have to subtract the beginning amount so that when I look at those coordinates, that is truly the length along the y-axis and the length along the x-axis. So I'm going to take y minus 15, so I'm going to get rid of the 15. So this, say I'm right here, this has to drop down 15 units to the horizontal axis, and it has to move over x minus 1, this 1 unit, to the origin. So now what that tells you is that every length along the y-axis for this line is going to be 6 times the length along the x-axis. And that makes sense because each hour you make $6. So in 1 hour you make $6, 2 hours you make $6 more, or $12, 3 hours you make $18, and so on. So this change along the y-axis is going to be 6 times the change along the x-axis. So figure this out as far as simplifying the equation to get in the form of y equals mx plus b. So this is y equals 6x plus 9. So now this point is on this line, and notice that if you go back 6 units from this 15 and start at 0, 15 minus 6 is 9. So this is going to be 9. This is going to be -3. So this is y equals 8x plus a -3. And here's how we got the slope right here. And this equation is y equals 6x plus 9. And this is how we got the slope right here. So notice that the difference along the y-axis is 12 units. So this point, this 9 to this -3 is 12 units, and it closes this gap 2 units every hour. So it goes from 12 to 10, and we knew this was 10. This is the 5 and 15 up here. So 12, 10, 8, 6, 4, 2, and then they finally intersect up here. So what this is saying is that regardless of the job that you choose, if you only work for 6 hours, you're going to make the same amount of money, $45. But if you're going to work longer, you want to choose the lesser amount in the beginning because the slope is greater. If you're not going to work as long, if you're going to work less than 6 hours, you want to choose the higher beginning amount because the slope is less, but it's not, it's always going to be more than what you earn in the other situation, this red line, or the first situation, because you're not working up to 6 hours. Now, a scenario could be to have 2 babysitting jobs. In one case, there's an emergency, the parents need to have a babysitter. So they say, look, if you show up at the door, I'm going to give you $9 to start with, and then I'm going to pay you $6 thereafter. So I'm going to give you $9 to start with and pay you $6 for each hour that you work thereafter. The other situation could be that the babysitter really wants the job. So that babysitter offers a $3 off coupon. So they're actually starting at a -$3, but they're going to charge $8 per hour. So they start at a -3, but then charge $8 per hour. So it's another scenario, another story that you could come up with to explain this situation. The point is to work with lines. I'm not sure why the authors chose to have a situation that really is not on a straight line.